Okay, so we have a practice problem. Find HCF using recursion method. Now to practice out recursion more, so I have included this practice problem here. So let's try to understand the logic behind our solution going to be. But let's attempt the program, then I will explain the dry run because you will not get what I am trying to say. Okay, so let's go into our code blocks. Okay, so we are here in our code block. So first of all, we have to be returning some value, okay? Because we are finding the HCF, and HCF logic is what? Let me just refresh your mind. So HCF is highest common factor. So if I have two numbers like 10 and I have 12, now what is 10 divided by? So 10 is completely 10 is divisible by 1, 2, it is divisible by also, I guess, 10, okay, and also 5. So 10 is divisible by 5, 10 is divisible by 10. Now 12 is divisible by 1, 12 is divisible by 2, 12 is divisible by 3, 4, 6, and 12 itself, okay? Now what is the highest common factor? Both of them. So the common value which is the highest of them all is 2. There is nothing else common in between them. So this is the basic concept of HCF, okay? So I hope you guys have refreshed your mind with the concept of HCF. Now we will be returning some kind of integer value as a HCF highest common factor. So integer HCF. So we will receive num1 and num2, okay? So now we will receive these two values. I will apply the logic if num2 received is not equals to 0, it is not equals to 0, then return what? HCF such that num2 becomes num1, num2 becomes num1, and num2 becomes num1 mod num2, okay? Yes, I know this is going to be a bit difficult, but we will get it. Else there is else situation, else return num1, okay? So return num1, okay? So now let's go and see whether we get a correct result or not. Integer num1, integer num2, see out, enter first number. So this is our first number and we get C in and we have num1, okay? And we say see out, enter second number, so which is C in and num2, okay? Now we will call our function that is see out, the HCF is equals to, we will call the HCF with num1 and num2. Okay, let's hope for the best. Will it work or not? Okay, we have some syntax issues. Num was, oh sorry, I forgot to mention the data types with these variables. So do make sure that you get to do this. So first number is 10, second number 12, and we have got 2. So we are getting the right result. So the HCF between 10 and 12 is 2. Now let me show you what is the logic behind this, okay? So let's have a look. All right, so we are here into the dry run. So what's happening here? We are receiving a number as n1 and n2. Up until now, it's okay, it's normal situation. So I have applied a logic that is n2 is not equals to 0. So this means if 12 is not equals to 0, this means that check if num2 is equals to 0 or not, okay? It checks that. So it made sure that num2 is not equals to 0. So 12 was not equals to 0. What it did, that it return an HCF value. So it return itself, means that it is a recursive function because it is calling itself again. But there is a slight change when it is calling itself. It changes the value of num1 and num2. So now the num1 becomes the num2. Okay, so now this 12 will be num1. When it is calling itself again, the 12 will be placed as a num1. And what's happening in the num2 is that we are calculating the remainder. So num1 divided by num1 mod num2 is equals to 10 here, because 10 mod 12 is equals to 10 remainder, because 10 is not completely divisible by 12. So we will get 10. Now our num1 is what? Our num1 is something else and num2 is something else. So when it calls itself again, num1 is 12 and num2 is 10. Now it checks if 10 is not equals to 0. Yes, because num2 is right now 10. As you can see, it is num2. So if 10 is not equals to 0, it says yes, it is true. Then it calls itself again. Num2 becomes num1. So now 10 was num2, so it becomes num1. And 12 mod 10. So now 12 it is will produce some remainder. How? It can be calculated like this. 12 divided by 10 is equals to 1.2, and 0.2 multiplied by 10 is equals to 2. So this is how you calculate the reminders. So 12 mod 10 will generate the result of 2. Now when it calls itself, it again checks the condition. If 2 is not equals to 0, then it is true. Then again it return itself by calling such condition that num2 becomes num1. Now 2 is 1, and 10 divided by and mod 2 is returned 0. Now 10 mod 2 is equals to 0. So then in fourth iteration, when it checks, it says 0 not equals to 0, it falls. Then it returns the value of what? It returns the value of num1. This is how you calculate the HCF. So if you still didn't get this, you can let me know in the comments, but I will recommend you watch this again and again, and I hope you will get the logic behind this practice problem. So I'll meet you guys in the next video, in which we will attempt our practice problem 3. Let's go.